Make sure he calls him.
Yeah.
Okay.
We were doing this problem, right? So we've got a car driving on a flat circular track. What minimum coefficient of static friction must exist between the tires in the road in order for the car to make the turn without slipping? If this is its speed and that's the radius of the circular curve, right? Okay, so what do? We just said this is kind of a modified free body diagram thing, right? Same stuff we've been doing, only it's a little weird because the car is moving in a circle, but at any one moment in time, if we were to look at the free body diagram, there's going to be two important directions. There's going to be the vertical direction in this case, and then there's going to be the direction that points towards the center of the circle, which we'll call the centripetal direction. What are the forces? Normal force pointing up, weight pointing down, and the frictional force is what's providing the centripetal force this time, right? If it were a satellite, it would be gravity. If it were a rock on a string, it would be tension. But in this case, it's friction. So what were the equations of motion? Well, vertically speaking, the net force is zero. They cancel, right? And so we'd say that the positive force, normal force, minus mg, because that's pointing down, would have to equal zero, just like we've always done with a lot of these questions, which means that the normal force equals mg, right? What about in the centripetal direction?
No.
The net force in the centripetal direction is just the only force, the frictional force, right? So that's going to be mu times normal force, but normal force is mg. So mu times mg would equal centripetal force, right? By Newton's second law, net force equals ma, but the type of acceleration this time is centripetal acceleration, right? So that's where we left off. So all we have to do then is solve for mu, right?
Cancel the M's.
I can cancel the m's. Good. And that makes sense, doesn't it? It shouldn't really matter. Doesn't it make sense to you that it shouldn't really matter what kind of car it is? We could be driving two different cars through the same turn, and in either case, they're gonna have the same experience, right?
Right. So if like you're driving a boat or a monster truck, it's gonna be the same.
It's gonna be the same. Yeah. Gonna be the same, assuming they have the same kinds of tires. Okay, so then what is mu sub s? All I have to do is divide by g, right?
Yeah.
Okay. So mu sub s equals the centripetal acceleration divided by g, right? That's it. That's the minimum, and think about the wording in the question. It says what minimum coefficient of static friction is required. So we need at least that coefficient of static friction for the car to stay on the turn. Could the coefficient be bigger?
Yeah.
Sure, be fine. It could be bigger, but it can't be less than that. If it's less than that, it's going to slide. Make sense? And so all we'd have to do then in this situation is calculate using what? This equation right here. Calculate what the centripetal acceleration is, and then just divide that by g, right? Does that make sense? So what do we get then for centripetal acceleration if we do that? We're going to get, here, we'll go up here. So
30.8 squared over
the centripetal acceleration is v squared over r, so 30.8 squared in standard units divided by 59.8, right? That's just a calculator question. So we go,
Mr. Witt, if
Yeah.
you didn't do physics, what do you think you would be doing?
I don't know. My life would be meaningless without physics. I don't know.
You didn't have any other aspirations?
Yeah,
I don't want to hear that.
I did. We'll talk about that later. 59.8, got my aspirations. Okay, so there's the centripetal acceleration, right? Divided by g, which is 9.8, is that. So that's kind of weird. That's saying that would require, you think this is going to be a difficult turn to make at that speed with that radius? Kind of looks like it. That's requiring a very high static coefficient of friction. I mean, that's almost unreasonably high. You can sometimes get static coefficients to be higher than 1 if it's really gummy rubber, right? But I don't think, honestly, I mean, and this is the answer to the question. We can always go back now and kind of reflect on the real situation and say, yeah, it's probably not going to work.
Well, I mean, you made the question.
I did. Yeah, I did. And honestly, it's irrelevant. It doesn't really matter if it's realistic or not, because this is oftentimes what you do with physics. Like in engineering, you'd be saying, okay, so what would we need? Oh, yikes, we can't do that. We got to go to plan B.
So to change that, to make it go down, what would you change in the problem?
You guys, okay, you tell me.
Slow down.
You could slow it down, or you could, what else could you do? Okay, bank it, but if we didn't bank it, what are the two options? If this is the equation for centripetal acceleration, I could either slow down, or I could what?
Decrease the radius.
Decrease? Increase, right. If I increase the radius, that's in the denominator, so that's gonna make the overall centripetal acceleration go down, which just makes sense. I mean, that would make sense to you, right? If you have a broader turn, you're not gonna have a need for as much centripetal acceleration. So we'd have to just adjust either the speed and or the radius of the turn.
Because the car is going 30.8 meters per second and the radius is almost 60, so it's like going around the turn in 2 seconds, isn't it?
Well, yeah, that'd be, well, that's the radius. But that's still, I mean, you can kind of picture that. That's not gonna really work. I mean, if you're going pretty fast in a car, because that's gonna be over 60 miles an hour.
Well, is that
And you're gonna try to make a turn, I mean, that's gonna be like, essentially like turning around in the length of a football field. That's probably not gonna
Is
happen.
the radius from the outside of the track to the very middle of the track?
It's from where you are, yeah.
So it's like going half the track in 2 seconds?
Well, so 2 pi r would be, I mean, you see, you're actually taking a part of the circumference, right?
Oh.
So it'd be pi r. So it's gonna be, I mean, yeah, it'd be like doing, you're gonna be traveling a distance of roughly 6 times about 180. So that would be like doing that in about 6 seconds, I guess. Seems like it's be less than that.
Yeah, I feel like.
Pi r, 3 times. Oh yeah, it would. 3 times 180. Yeah, no, it'd be about between 5 and 6 seconds. But still, that's probably not gonna happen. That's going pretty fast. If you saw that turn on the freeway, you'd be thinking, oh no, that's kind of a pretty tight turn. Right?
That's like the one, like when you're going to the
Yeah. Yeah, they're not gonna have a posted speed there of 60 miles an hour. That's gonna be like a 25 miles an hour speed, yeah. Anyways, that makes sense? So that would be the answer, though. It'd be 1.62 rounded to 2 places. Okay? All right, the last one. Okay, so the last one, and I'm not gonna spend a lot of time because this is a bonus question, but I'll just orient you on this. This is only worth, I think, like 1 or 2 points on the test. It's just like that very last little bit to get 100%. But think what this is saying, a very large frictionless track in the shape of a conical pit is banked at a 43.1 degree angle. A frictionless puck would need to slide on a trajectory how far up the track, so measured along the surface of the track, in order to be able to keep a constant speed of 59.5. So I will help you draw the picture. So here's what the picture would look like. In cross section, this is what the track would look like. Right? And then it's just gonna kind of go around like that.
So you're taking like a slice of the track, right?
Yeah, I just cut right through the middle of the track. Right.
Alright.
And so what it's saying is, if this angle right here is 43.1 degrees, and it wants to maintain, so here's the object right here, let's say, and it's just gonna be traveling around the track like so. We wanna know, in order for it to go 59.5 meters per second, what is this distance right there gonna be? Okay, that's what they want. That's a tricky one, right? I mean, you'd have to be thinking, here's kind of the maybe one other little hint. This is gonna be the axis right up the middle. So the circle right here is actually in that plane right there, isn't it? So you kind of have to know what that distance is right there, wouldn't you? Right? For a certain speed, what does that distance need to be, right? Okay, because the V is 59.5, but what's R gonna be? Well, that's really the R for your circle. Okay, and then you'd have to translate that into a distance right there, but you could do that.
You're recording.
Because there's a triangle. Yeah, I am. Okay. That's a tricky one. Like I say, that's the bonus. It's only worth like 1 or 2 points.
Should be worth -1. If I get it wrong.
You get it wrong, you get it right. Okay,
If you did it right, you did it wrong.
I think you're good.